Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture I will explain arrange the following in decreasing order of reactivity towards SN1 reaction. 8 questions are given. I will explain one by one. Let's start. SN1 means substitution nucleophilic unimolecular. This type of reaction takes place in 2 steps. At the first step, slow ionization of the substrate takes place and a carbocation, this is carbocation, or you can say carbenium ion, is formed as reaction intermediate. This is slow step. And at the second step, step 2, this is rapid step. Incoming nucleophile attacks the carbocation and the product is formed. This is your product. So this is 2 steps reaction and the first step is the slowest step. So it is the rate determining step. Since carbocation is formed at the rate determining step, if the carbocation is more stable, then the reaction takes place easily. Now one by one we will solve the problems. Now for the first question, 4 compounds are given. So everywhere CCl bond will break at the first step. Carbocations are these. Now see, this is secondary carbocation because with this carbon 2 more carbons are attached, but these 3 are all primary, means 1 degree carbocations. Because with each carbon only 1 carbon atom is attached. So secondary carbocation is more stable than primary carbocation. So this carbocation is most stable. But what is about all those 3? Adjacent to this carbocation, this carbon atom is alpha, this carbon atom is alpha. Here no alpha carbon atom is present. With the alpha carbon, alpha hydrogens are attached. So here how many alpha hydrogens are there? 3 alpha hydrogens. Here 2 alpha hydrogens. And here 0 alpha hydrogens. So here 3 hyperconjugative structure, here 2 hyperconjugative structure, here 0 hyperconjugative structures are possible. So the more the number of hyperconjugative structure, more is the stability of carbocation. Therefore, between these 3, this is the most stable carbocation, this is the last one. So, if the stability order of carbocation is this, then decreasing order of reactivity for SN1 reaction is also this. This is most stable carbocation, so this is most reactive compound. This is next, so here this is next reactive, like that way. Hope it's clear to you. Next question. Now for these 3 compounds, first break CBr bond. So what carbocation is generating here? Now see, this carbocation is primary carbocation because with this carbon only 1 carbon is attached. This carbon is secondary. This is secondary carbocation and this is also secondary carbocation. So secondary carbocation is more stable than primary carbocation. But these 2 are secondary. But see, this is allylic. So this is allylic, secondary. So it will be stabilized by resonance and also inductive and hyperconjugative effect of this methyl. Here at the end this is there, means here carbon and 3 hydrogen atoms. So this CH3 group is having plus I effect and hyperconjugative effect. So this carbocation is stabilized by resonance effect of this group and plus I and hyperconjugative effect of this group, methyl group. But here this carbon atom is stabilized by hyperconjugative effect of this methyl and this CH2 group. Here this is methyl. And here how many carbon, 1 carbon atoms and how many hydrogen? 2 valences are satisfied and here 1 hydrogen and here one hydrogen atom is there. So only here plus I effect and hyperconjugative effect is operating. Hyperconjugative effect and plus I effect. Since here resonance is there, so this is most stable carbocation. And here only hyperconjugative effect is there. So stability order of carbocation is 2 is the most stable, then 3 it is secondary, then last one is this primary. So this is the order of SN1 reactivity also. 2, then 3, then 1. Here 3 compounds are given. So first break CBr bond. Here you will get the following carbocations. Now see, this carbocation is stabilized by resonance with this double bond because it is at conjugated position. Here double bond, single bond, positive charge, single bond, double bond, single bond, then double bond. So fully conjugated system, cyclic, planar, but it is having 4 delocalized pi electrons. So it is 4n pi electron. So it is anti-aromatic, highly unstable. And this carbocation, positive charge, single bond, double bond, single bond, lone pair on nitrogen, single bond, then double bond, then single bond, then positive charge. Fully conjugated system, cyclic, planar, and it is having 6 delocalized pi electrons. So it is cyclic, planar, having 6 delocalized pi electron means it is having Huckel's number of pi electrons where n is equal to 1. So this is aromatic. It is highly stable carbocation. So stability order of carbocation is first 3, then 1, then 2. So this will be also the order of reactivity towards SN1 reaction. Next is this 4 compounds. So first for SN1 reaction, break this CBr bond. But here what will happen, this is benzene ring. Here bromine atom is attached with that sp2 carbon. So due to resonance, this CBr bond is having some double bond character. So it's very difficult to break this bond. So it is least reactive here. Now here what carbocations you will get? So this carbocation is tertiary because with this carbon 3 carbon atoms are attached. So this is tertiary benzylic. So with the benzene ring, due to resonance, this carbocation is stable, and also due to inductive and hyperconjugative effect of these 2 methyl groups, this carbocation is stable. Here this is benzylic 1 degree benzylic carbocation. This is also 1 degree carbocation. So here due to resonance, hyperconjugation, inductive effect, this is the most stable carbocation. Here resonance is there with the benzene ring because positive charge, single bond, double bond are in conjugation. And here resonance is not possible with benzene ring because positive charge, single bond, then benzene ring is there. But here hyperconjugation with this hydrogen atoms will take place. So here hyperconjugation is there. So which one is the most stable one? This one is the most stable carbocation. Then this one, because here resonance is there, here no resonance, only hyperconjugative effect is there. And this is the least stable carbocation. And here this is least reactive compound because here CBr bond is some double bond character due to resonance. And here if this bond will break, if this CBr bond will break, we will get this carbocation. And this is highly unstable because it is not stabilized by resonance. So what is the stability order of carbocation? This, and this is least stable. So reactivity order of the substrate are in this order. It is decreasing in this order. Now see, this is benzyl bromide Here at para position of benzyl bromide, OH group is there. Here at para position of benzyl bromide, CH3 group is there. Here at para position of benzyl bromide, nitro group is there. Now, first what you have to do, you have to break the CBr bond. So, what carbocation you will get? You will get these carbocations respectively. So, here at the para position of this carbocation, OH group is there which is having plus R and minus I effect, but plus R effect is much more stronger than inductive effect. Here at the para position, plus I effect is there, hyperconjugative effect is there. Here no substituent is there. Here electron withdrawing nitro group is there at para position. So it is having both minus R and minus I effect. It is electron withdrawing group. So due to plus R effect, it will stabilize the carbocation most. Then due to hyperconjugative effect and inductive plus I effect, it will stabilize the carbocation. Then unsubstituted one is more stable than if here electron withdrawing group is there. If electron withdrawing group is there, it will abstract electron density and positive charge density on this carbocation will increase, it will destabilize the carbocation. So stability order of the carbocation is this, and this is the same for the reactivity towards SN1 reaction. So this is the reactivity order also. Now for this set, first break CBr bond to generate carbocation. This carbocation is tertiary benzylic. So this is stabilized by resonance and also inductive effect and hyperconjugative effect of this 2-methyl group. This carbocation, from here we will get this tertiary carbocation. This is stabilized by inductive effect and hyperconjugative effect, inductive effect of CH3 and also hyperconjugative effect of these alpha hydrogens. Here carbocation is this one. This carbocation is secondary, and here you will get this secondary carbocation, but adjacent to that carbocation one electron withdrawing group is there which makes this carbocation unstable. So this carbocation is most unstable. Due to this electron withdrawing group, here positive charge density on this carbon atom will increase and it will make this carbocation unstable. So what is the stability order of the carbocation? These two are tertiary, and here since C6H5 group is there, so resonance effect is also there. So this is the most stable carbocation. Next this one, and here between these two, this carbocation is most stable due to inductive and hyperconjugative effect of methyl groups, and here due to electron withdrawing effect of RCO group. Here in R CH3 group is there. So this group makes this carbocation least stable. So this is the stability order of carbocation. So reactivity order for SN1 reaction will be this one. Now for this set of compounds, we have to find out the reactivity towards SN1 reaction. So first you break CBr bond. What carbocations you will get? First write down that one. Now you will get these carbocations respectively. Now see, all the carbocations are tertiary, means third degree benzylic. So these will be stabilized by resonance effect with benzene ring and also hyperconjugative inductive effect of methyl groups, 2 methyl groups. And here at the para position one cyclopropane ring is there. Here also one cyclopropane ring is there. Here no cyclopropane ring. Here at meta, with respect to this at meta, methyl group is there. Remember, the bond in cyclopropane are called banana bond or bend bond. This bond is intermediate between sigma and pi. So cyclopropane behaves like double bond compounds. So if here one double bond is there with respect to this carbocation, it is para. So conjugation will be there. Here also conjugation will be there, but here no cyclopropane ring. So due to this ring, no conjugation is here. And here at the meta position, methyl group is there, so it is having inductive effect. Because at meta position, hyperconjugative effect is not important. Here inductive effect, plus I effect is important, and it will stabilize this carbocation. And here CH3 group is not present at meta. So here it is not stabilizing the carbocation due to inductive effect, but it is stabilizing the carbocation due to this cyclopropane ring. So between these two, this carbocation is stable, and between these two, which one is more stable? This is more stable, because here no cyclopropane ring is there at the para position. So if stability order of the carbocation is this one, then reactivity order towards SN1 reaction is this. Now for this set of compounds, first break this CCl bond, and see here this Cl atom is attached with sp2 hybridized carbon. So here it's difficult to break, because here lone pair is involved in resonance with this double bond, and it will have some partial double bond character. It's very difficult to break this bond. So it is least reactive. Now between these two, what carbocation? Here you will get this carbocation, and from here you will get, this is called cyclopropyl methyl carbocation. So here it is cyclic conjugated, because double bond, single bond, positive charge, single bond, double bond. So it is cyclic conjugated, but it is having two delocalized pi electrons. Means it is having 4n plus 2 delocalized pi electrons, where n is equal to 0. So it is aromatic, because it is cyclic, it is planar, it is fully conjugated, having 4n plus 2 delocalized pi electrons. So this is aromatic, means this carbocation is highly stable. So between these two, this carbocation is more stable than this. This carbocation is getting stability due to the banana bond or the bent bond of cyclopropane ring. And here it is not easy to break this bond. So reactivity order will decrease in this direction also. Hope it's clear to you. If you like, please subscribe. Thank you for watching.